Welcome to today's tutorial. In the course of today's tutorial, we'll be talking about what? Shear force and bending moment. Now, before we talk about shear force and bending moment, let's start with the introduction to what? To shear force and bending moment. Now, let's talk about beams. Beams are structural elements that resist load. Beams are structural elements that resist load. Now, what are the types of beams? Basically, we have two types of beams. You can take this down. Basically, we have two types of beams. The first one is what we call statical determinate beam, and the second one is what we call statical indeterminate beam. So the first one is what we call what? Statically what? Determinate beams. And the second one is what we call statically indeterminate beams. So you might be asked, name two types of beams, or dash and dash are the various types of beams. What should come to your mind are, we have what? Basically what? Two types of beam. The first one is called what? Statically what? Determinate beam, and the second one is statically indeterminate beam. Both of them, they are statically, but what? One is determinate and one is what? Indeterminate. Now, what is a statically determinate beam? The statically determinate beam are those beams that obey the law of what? Static equilibrium. The statically determinate beam are those beams that obey what? The law of static equilibrium. While the what? Statically indeterminate beams are those beams that do not obey the law of what? Static equilibrium. Now, what are the law of static equilibrium? Basically, we have three laws of static equilibrium. We have three laws governing what? Static equilibrium. Now, what are they? The first one is sum of forces along the y-axis is 0. The first one is sum of forces along the y-axis is 0. The second one is sum of forces along the x-axis is what? 0. While the last one is sum of moments at a point is what? 0. Now, the first one, mathematically, it is what? Summation of what? Fx is equal to what? 0. That is the sum of forces along the x-axis is 0. The second one is summation of what? Fy is what? 0. That is sum of forces along the what? Y-axis is what? 0. While the last one is sum of moments at a point is what? 0. The first one is what? Sum of forces along the what? X-axis is 0. The second one is sum of moments at a point is what? 0. While the last one is what? Sum of forces along the y-axis is 0. So you might be asked, give the laws of what? Static equilibrium. We quickly remember that summation of fx is 0, summation of fy is 0, and summation of moment at a point is 0. Now let's talk about the first one, which is statical determinate beam. I told you the statical determinate beam, they are those beams that what? They obey the law of what? Static equilibrium. Now, what are these beams? Examples of the statical determinate beam. Now, the first one we want to talk about is what? Is our statically what? Determinate what? Beams. Now, basically, we have 4 statical determinate beams. The first one is what we call, for the statical determinate beam, I want to give you an example. The first one is called the cantilever beam. The first one is what? The cantilever beam. The first one is called the cantilever beam. Now, what is the cantilever beam? The cantilever beam is a beam. The cantilever beam is a beam where your support is fixed at one end. The cantilever beam is a beam where your support is fixed at one end of your beam. So you have a beam to be this. The cantilever beam, the support is at this end of the beam, is fixed at one end of the beam. So this is your support at this end. And the support is what? Is fixed. Your cantilever beam is a beam where what? One end of that beam is being what? Fixed. Example of the cantilever beam is our normal door. The one we open and close is an example of a cantilever beam. Now the second one under the what? Statical determinate beam is what we call the overhanging beam. The second one is what we call what? The overhanging beam. Now what is the overhanging beam? The overhanging beam is a type of beam, is a type of what? Statically determinate beam where your support is not necessarily placed at both ends of your beam. Now, if you have a beam of this manner and they said the support is not necessarily placed at both ends, so your support might be at this point, your support might be at this point, or this support, or you have a beam like this, your support might be here or at this point. It's not necessarily placed at the both ends of the beam. They are not placed at both ends. The support might be placed in the same line, opposite line, or they might just be placed, but they are not placed on both ends. Now the next one which we talk about under the statical determinate beam is what we call the simply supported beam. Under what? The statically determinate beam. The next one which we'll talk about, that's number 3. Number 3 under this is what we call the simply supported beam. Now what is the simply supported beam? The simply supported beam, these are beams that the support is placed at both ends of your beam. The simply supported beam is a beam where your support is placed at both ends of the beam. So if you have a beam of this manner, your support will be at this end and this support will be at the other end. So your simply supported beam is that beam where your support is at both ends. Note, we are not talking about fixed support. We are just talking about the support. The support is at both ends of your beam. The first one which we talked about was the cantilever beam, and we said the cantilever beam, one side of the beam is what? Is being fixed. But your overhanging beam and your simply supported beam, they are just support being placed on a beam. But the overhanging beam, we said, is a beam where your support is not necessarily placed on both ends. But your simply supported is a beam where your support is placed at both ends of that beam. So note the difference between these beams. But know that all these beams which we are talking about, they are under what? The statically determinate beam. Now the last one which we'll talk about is the fixed beam. The last one which we talk about under the word statically determinate beam is what we call number 4 is what? The fixed beam. Now what is the fixed beam? The fixed beam is a beam where your support is fixed at both ends of the beam. So if you have your beam to be of this manner, your fixed beam will be at this end and the other one will be at this other end of this beam. So you have your beam fixed at both ends of this what? Beam. the support is fixed at both ends of the beam, while the overhanging beam, they are placed, it is just placed. The support is placed at both ends, while your overhanging beam, not necessarily at both ends. While your cantilever beam, it is fixed at one end. So you should know the difference between the fixed beam, the simply supported beam, the overhanging beam, and the what? The cantilever beam. Now the next type of beam which we talked about was what? The statically indeterminate beam. And we said the statically indeterminate beam, they do not what? Obey the what? The law of static equilibrium. Now what are the statically indeterminate beam? So you can take this down. Examples of the statically indeterminate beam. Now the first one which we have for statically indeterminate beam is what we call the continuous beam. A continuous what? Beam. And what is a continuous beam? The continuous beam is a beam that has more than two supports. The continuous beam is a beam that what? That is characterized by more than what? Two supports. So any beam that has more than two supports is called your continuous what? Beam. Now we've been talking about supports. What is now the support? Basically in this course we have three types of support. So you can take this down. Types of what? Support. Now the first type of support we'll be talking about is what we call the hinge support. The hinge support. The first one is what we call the hinge support. Now the hinge support is characterized by what? Two reactions, or it is characterized by two reactive forces. The hinge support is a type of support that is characterized by what? Two reactive forces. So if you will have a support like this. You have a support of this manner. Now, if you see this support as this course goes on, you know that what? This is a what? A hinge support. Now, we said the hinge support is characterized by what? Two reactive forces. Now, the first one is the reactive forces. We have a reactive force towards the y-axis. So we have a reactive force like this, arrow y, and we have another reactive force, arrow x. The next type of support which we'll talk about is what we call the roller support. So number two. The next support which we'll be considering is what? The roller support. Now the roller support is a type of support that is characterized by one reactive force. Your roller support is a support that is characterized by what? One reactive force. Now if you have a support of this manner and you see this is what? A roller support. And we know that a support is any material that is placed under the beam. That is your support. Now, if you have a support of this manner, this is what? A roller support. And we said it is characterized by what? One reactive force. Now, what is the force characterized by? The roller support moves only horizontally. So it's having a reactive force, RY. That is the only reactive force your roller support will have. But if they ask you, if you are seeing a hinge support in the question, then you know that you have to calculate for your two reactive forces. But if the question is having what? A roller support, then you know that what? Your roller support is characterized by what? One reactive forces. That's the reaction towards the what? Y-axis. Now the last type of support which we'll talk about is what we call the fixed support. The fixed support. So the last one is what we call the fixed, F-I-X-E-D, fixed support. Your fixed support is that support that is characterized by what? 3 reactive forces. Your fixed support is that support that is characterized by 3 reactive forces. Now let's take an example. Let's take an example from statical determinate beam. The first one which I gave you, that was the cantilever beam. Now I said the cantilever beam is a beam that has what? Only one support at one end of the beam. Now if you have the cantilever beam to have a fixed beam, this is the beam. The beam is placed at one end and is what? Fixed. Now the fixed beam is characterized by 3 reactive forces. Now we have the force. We have the arrow y, that's the upward force. We have this force, arrow x, the force towards this direction. Then we have the last force, which is the force due to what? Rotation. So let's call this arrow what? Z. So we have 3 reactive force. We have this force, we have the upward force, and we have the what? The force due to what? The movement, the rotation. So if you are asked in a question to calculate for a type of beam and you are seeing these supports, then what should come to your mind is to calculate for those supports. Now the next thing we talk about is types of what? Load. Basically we have 3 types of load. The first one is what we call point load. Now if you have a beam of this manner and we have something like this, we have another one like this. This is called what? Your point load. This is your point load. So as this course goes on, you see diagrams and you see graphical representation of some certain things, and you are seeing these arrows. You know that these arrows, they are what? Your point load. But when you are seeing all this, you know that they are what? They are called support. Now the second one, which we talk about, is what we call the UDL load. The UDL load. Now somebody will ask me, what is the UDL? The UDL load is also called the uniformly distributed load. So if you are not seeing UDL and you are seeing uniformly distributed load, then you know that the load they are talking about is what? Is a UDL load. And when you see something like this also, let's say this is our beam. Let's say this is our beam. And you have a load. You have a load, this. You have a load of this manner. This load is called a UDL load. And you know that the UDL simply means what? Uniformly what? Uniformly distributed load. So if you are not seeing the UDL and you are seeing uniformly distributed load, you know that this is what is a type of load and is a what? A UDL load. Now the next load which we talk about as this course goes on is what we call the varying load. Number 3. Varying what? Varying load. Now, the varying load is also known as this is uniformly. Now, the varying load is also known as non-uniformly distributed load. It might not be called varying load. You might be seeing non-uniformly distributed load. You know that your non-uniformly distributed load is your what? Is your varying load. Now, if you see something like this also, if you are not seeing it in the question, and you are seeing something of this manner, this is a load. Now, if you see this load, you know that this load is your what? UVL, or your non-uniformly distributed load. Now, this UVL means what? Uniformly varying load. That's the meaning. So if you are not seeing uniformly distributed, non-uniformly distributed load, you'll be seeing UVL. And you are not seeing UVL, you'll be seeing what? Varying load. Now we've talked about the support and the load. So when you see all these parameters in the questions, you might not be confused. Now this is the basic introduction to what? This is the basic introduction to shear force and what? Bending moment. Now let's take some calculations so we understand this course better. Let's solve some problems. How to determine. Now let's determine how we can solve problems and we can give the graphical representation of what? Shear force and bending moment. Now take down this. A simply supported beam of span 9.0 meter. A simply supported beam of span 9.0 meter carries a load of 864 kilonewton. Carries a load of 864 kilonewton. Concentrated and acting at the center. Concentrated and acting at the center. Draw the shear force and bending moment diagram. Draw the what? Shear force and bending moment diagram. Now see what we were given. We are given question 1. The diagram is this. We are given this diagram and they said this load is 864 kilonewton and we are given a reaction. You are given a support RE and you are given another one RB. And this is 9.0 meter. They said this is A and this is B. I think that's all. They said we should draw the shear force diagram. They said we should draw the shear force diagram and the bending moment diagram. Now to do that, the first thing you do, take down steps in calculating for your shear force and your bending moment diagram. Steps in calculation for your shear force and bending moment diagram. Now the first step is choose a reference point. The first thing you do is what? You choose what? A reference point. That's the first thing you do. So step 1. Steps. The first thing is what? Choose a reference. Choose a reference what? Point. The next step is, after choosing your reference point, take moment to the chosen point. The second step is, take what? Take moment to the what? To the chosen reference point. And when taking moment to that point, which you chose to be your what? Reference point, moment will be what? 0. Now what is the next thing? The next thing is, take anti-clockwise moment and clockwise moment to the what? To the reference point. The third step is what? The third step is what? Take anti-clockwise moment and clockwise moment to the chosen The next thing is what? Take anti-clockwise movement and what? Clockwise movement to that what? Chosen point. That's the next thing. Now, let's use this step in solving this problem. Now, the first thing we'll do is what? Is our solution. The first thing is what? Choose your reference point. Take your reference point to this point. I will tell you, take your reference point to this point B. We have this point A and this point B. Take your reference point to this point. Now, the first thing is what? Take reference point to B. Now we are taking our reference point to this point. Now, what's the next thing? Take moment to the chosen what? Reference point. Now, this is what we have. We've chosen our reference point to be B. The next thing we'll do is we are taking moment to this point. And what is the moment we are taking? We are taking what? Anti-clockwise movement and clockwise movement. Now, this is the first one. This is the first reaction. This is the first reaction. So we can call this what? RUAY, and we can call this what? RUBY. Now, we are taking moment from this point, which is clockwise, to this point. And we are taking moment from this point, which is what? Anti-clockwise, to this point. We know that when we are taking clockwise is moving like this, anti-clockwise is moving what? Like this. Now, this is what? This is anti-clockwise. Why this is what? This is clockwise. Now, we are taking clockwise movement and we are taking what? Anti-clockwise movement. Now, the next thing we have to do is taking moment from point A to point B. You are taking moment with respect to their what? Their perpendicular distance. So now we are taking moment from this point to this point. Now the next thing is to take moment. What you do is you use the formula sum of what? Clockwise moment is equal to sum of what? Anti-clockwise moment. What are we doing? We are taking what? Sum of clockwise moment and we are taking what? Sum of anti-clockwise moment. Why are we doing this? We are doing this so that we'll get our what? Our reactions, because they didn't give us our reaction. And it is from the reaction we can calculate for our shear force and our bending moment calculation that we use to plot our shear force and bending moment data. That's why we want to get the both reactions that we are given in the question. Now, to get these two reactions, what are you doing? You are taking the clockwise moment and you are taking the what? Anti-clockwise moment with respect to their what? Their distance. Now, taking the clockwise moment, which we know that our clockwise moment is what? RA. Now, if we take RA from this point down to point B, is what? We are taking it RAY plus times what? We are taking RAY multiplied by what? The total distance. So this is what? RAY. And what is the distance from point A to point B? Multiplied by what? 9.7. And this is equal to, what is the sum of the anti-clockwise? We know that this is an anti-clockwise. So you can label this to be anti-clockwise, then you can label this to be what? Clockwise. Anti-clockwise, we have what? 864. And what is the distance? We know that from this point down to this point, this is 9. So half of this will be what? This will be 4.5 and this will be what? 4.5. So we are taking from this point down to this point. And we have what? 864 multiplied by what? What is the distance? Multiplied by what? 4.5. Now if you do that, we will arrive at what? This will be what? 9 RAY is equal to, punch this with your calculator, what will you have? You have what? You have what? 3888 if you punch this with your calculator. So what do you do to get your RAY? Now to get your RAY, you simply do what? RAY is equal to divide both sides by what? 9. So this is 3888 divided by what? 9. So you can guess your RAY. And what's your answer? 432 kilonewton. Now we've gotten this reaction. The next thing is for us to get our RBY, which is the next reaction. Now to get this reaction, what do we simply do? We simply say what? Sum of what? Sum of upward force. Sum of upward force is equal to what? Sum of downward forces. Now, what are upward force? Our upward force are the two reactive forces. And what is the downward force? The load, the point load. Now, the summing the upward force, which is what? RAY plus what? RBY is equal to, what are the downward force? The downward force, the only downward force we have is what? 864 kilonewton. So we have what? 864 kilonewton. Now we already know our RAY, which is what? 432 kilonewton. So substituting what we have here is what? We have 432 kilonewton plus what? RBY, and this is equal to 864 kilonewton. What do we do to get RBY? We are taking this to the other side of the equation, collecting like terms. Now, if we collect like terms, we have what? RBY to be what? 864 minus 432. Now, if you punch that with your calculator, 432 kilonewton. So you've gotten your reactive force for RAY, and you've gotten your reactive force for what? RB. This is your reactive force for RAY, and this is your reactive force for what? RB. Now we've succeeded in getting the reaction. Now to get your shear force diagram, you take the next step. To get your shear force diagram, you are going to do what? The calculation for your shear force, and you are going to do a calculation for your what? Bending moment. Now take down calculation for what? Shear force, or you can take this down, shear force calculation. Now the next thing we have to do is to what? To do our shear force calculation. Shear force calculation. Now, doing our shear force calculation, we'll get the shear force for this one, for point A, we'll get the shear force for this load, and we'll get the shear force for point B. That's what we'll do. Now, the first one which we'll do is the shear force for point what? A. Now, for you to get the shear force at point A, now let's take this instance for more clarification. Now, let's say you are at point A, you are standing at point A. What is the force you are seeing at that point? Let's say you are at this point. You are at point A. This is you. You are standing at this point. What is the force you are seeing at this point? It is what? RAY. It is what? RAY. Abi? Now, haven't you calculated for the force you are seeing here? You've calculated for the force, which is what? 432 kilonewton. So now the force for point A, the shear force for point A is what? 432 kilonewton. Now, what's the next thing? To get the force, shear force for what? For the midpoint. Now, shear force for the midpoint, let's use it as SF. Let's represent it as SF. Now, to calculate the shear force at the midpoint, that's what we want to get now. Let's say you are standing at this point. Now, you are standing at this point. You are not considering what we have here. You are not looking at, don't look at what we have here. Your concentration should be what we have here. Now, we are standing like this. You are at that point. Now, for you to get the shear force for this point, for the midpoint, is you are standing at the midpoint. Look at those forces you are seeing here. What are the forces you are seeing here, and what is the force you are seeing at that point? Now, the forces you are seeing is this point here and this one here. So it is simply what? This force, which is a positive force. So you have plus, what is this force here? 432. And what is the force you are seeing at that point where you are standing? It is what? Negative force. It's coming down, which is the load. It's a negative force and it's a load. And what is the force? 864 kilonewton minus what? 864 kilonewton. Now, if you do this, what will you have? Minus 432 kilonewton. Now, what's the next thing? You are now at point B. You are standing at point B. You are standing at point B. You are considering what you are having here, not what you are having here. Now, if you are at point B, what are the forces you are seeing on this side of the board? You are seeing this force, you are seeing this force, and the force where you are standing. Abi? Now, to calculate for this force at that point where you are standing is you are considering this force, the upward force, which is the positive force, and you are considering the load, which is what? The negative force, and this force you are seeing here, and it's a what? A positive force. Now, to calculate for shear force at point B, shear force at point B is simply what? What is the force you are seeing here? The force you are seeing here is what? 432 kilonewton, and it's a positive force. What's the next force you are seeing? The negative one, which is what? 864 minus 864. What is the next one you are seeing? It's a positive force. So this is what? Plus this Arubi. We know Arubi, and Arubi is what? 432. Now, if you do this calculation, you simply arrive at what? 0. We talked about our shear force calculation. Now, let's talk about our bending moment calculation. Bending moment calculation. Now, for your bending moment calculation, the first thing we are calculating is bending moment at point A. So for bending moment at point A is what? Now let's say you are still at point A, you are standing at point A. And we know we want to calculate for what? Bending moment. And moment is what? Force multiplied by what? Distance. That's moment. Now, if we want to get the bending moment at that point, we are taking the force with the what? That is what you do to calculate for bending moment. Now, let's say you are standing at point A. Now, if you are standing at point A, what are the force coming to point A? You are not seeing any force on this side. This is what we are considering, not this other side. Now, we are at point A. What is the force you are seeing at point A coming to point A? We are not seeing any force coming to point A. We are not seeing any force coming to point A. Forget this one. This one was the anti-clockwise force we took. Now let's remove this one. Let's remove this. Let's also remove this. Because we've gotten for the reaction we wanted to get. Now look at your diagram. You are standing here. What is the force you are seeing here? There is no force at this other side. So your bending moment at point A is always what? 0. Now let's get the bending moment for your midpoint. Bending moment for what? Your midpoint. Now, for you to calculate for bending moment for your midpoint, you simply what? You are standing at the midpoint. What is the force you are seeing on this side, and what is the distance from that force you are seeing to the force where you are standing? Now, you are standing at this point. Now, you are not at this point. You are standing at this point. What is the force you are seeing at this point, and what is the distance that force is taking from that point to the point where you are standing? Now, you are here. What is the force you are seeing? This is the force, arrow wise. So your arrow for bending moment for the midpoint is what? Is simply arrow AY, which is this, with what? Your distance, which is what? 4.5. So your arrow, your bending moment at the midpoint will simply be what? Arrow AY multiplied by what is the distance? Multiplied by what? 4.5. Now to do that, we know our arrow AY to be what? 432 times 4.5. Now if you do that, you get the bending moment for the midpoint. You simply arrive at 1944 kilo Newton. Now let's get the bending moment at point C. To get, now you are not at this point anymore. You are at point C now. You are standing at. To get the bending moment, the next one is bending moment at point B. Now you are at this point, you are standing at B. You are standing at B. What is the force you are seeing on this side and what is the distance that force is taking for it to get to where you are standing? Now we are at point B. We are seeing this force and we are seeing this one. We know that this one is a negative force and we know that this is a positive force. Now we are taking the distance from this place down to this place, which is what? 9. And the next one is what? The negative, which is minus 864. From here down to this place is what? 4.5. So this is simply what? This is simply what? Arrow AY, which is what? 432. What is the distance? Multiplied by what? 9.0. Minus, what is the next one? 864 multiplied by 4.5. Now punch that. What do you have? 0. Now the bending moment at point B is always what? 0. The bending moment at that point where you took your moment to is always what? 0. Now with your calculation, you can simply what? Give the graphical representation of shear force and your what? Your bending moment. Now let's go into the graphical representation of our shear force and bending moment. We want to show the graphical representation of our shear force and our bending moment. Now I told you the first thing you do is to what? To redraw this diagram again. Now we are drawing what we have here. Drawing what we have here, we have that to be what? We have that to look like this. Now they say the point load is acting at the midpoint, and this is what? 864 kilo Newton. We have this support, which is RP, and we have this other support, which is what? RP. What next? He gave us the distance from here to this point to be what? 9.0. That was the diagram. Now, you want to draw your diagram. The first thing is you come to where you are seeing your first support. You rule down a faint line. So you are using the board. So you rule down a faint line. The next thing is come to where the load is given to you. Rule down another faint line. Then you come down to RB. You rule down what? A faint line. Now what you do is you draw a horizontal line. This horizontal, the first one, you call it what? Shear force line. So the first one is your shear force line. Then the next one is your what? Your bending moment line. So this is your bending moment line, and this is your what? Shear force line. It must not really be to scale. In fact, it must not be to scale. Now, the first thing for your shear force at point A, this is your shear force at point A. This is your origin. This is 0. This is 0. This is your origin. Now, the shear force at point A, is it positive or negative? It is what? It is positive. Now, this is our positive. This is our negative. This is our positive for bending moment, and this is our what? Negative for bending moment. So any negative you are seeing here will fall under this place for shear force, and any negative for bending moment will be under this line here. The first one we have is what? 432 kilonewton. So now from this place down to this place, let's call this 4.432 kilonewton. This is the shear force for point A. Now the next one, at the midpoint, we have a negative shear force. A negative what? Shear force. So we are coming what? Down. So we are drawing this. All this part is a negative shear force. So this is our what? 432 kilonewton down to this point is our what? Shear force for the midpoint. Now, shear force at point B is what? 0. So we are going back to the what? Origin. We are going back to the origin. So this is your positive and this is your what? Negative. So you can do this. Now this is your what? Your shear force diagram for this what? Structure or for the beam given. And the next one is to get your bending moment diagram. Your bending moment diagram, we always represent it as a slanted line. How? The first one is what? Bending moment at point A, it is 0. So bending moment at point A is at this point, 0. The next thing, bending moment at the midpoint, that is at the middle, it is what? A positive what? 1944 kilonewton. So from this point down to this point, it is what? 19 what? 1944 kilonewton. Now, bending moment at point B is what? 0. So from the midpoint, you are coming down to what? Point B, and it is what? 0. So this is positive and this is positive. And even if it was at this bottom, it will be what? In negative. But since the bending moment is what? Positive, it is what? Positive. So this is your shear force diagram, and this is your what? Your bending moment diagram.